Hey guys, thanks for tuning in to the Keto Answers podcast. I'm your host, Dr. Anthony Gustin, and joining me this week is Dr. Thomas Seyfried. Doc here blew my mind. There was a lot of information in this one. He has done so much work in the field of cancer and using ketogenic diet for cancer. Started researching epilepsy and seizures, and that brought him to using ketogenic diet and a whole bunch of different things to treat cancer. His approach is very, very different from standard of care. He does not think that anybody should be using what he calls poison, chemotherapy for cancer treatment, and he thinks that there's a much, much better way. So if you're interested in that, I was, obviously. So take a pen and paper and get it out. There's a lot of notes here. So many people are affected by this stuff. Cancer rates, I know we've mentioned this in a previous episode, are 1 in 2 in men in the U.S. now, and 1 in 3 in women. So I mean, something that's just critically important. We're not solving that problem. So people like Dr. Seyfried here are a huge part of the puzzle to try to move it in the right direction. So tune in, and I hope you enjoy. Before we get to the episode, I wanted to chat about our sponsor, Perfect Keto. Perfect Keto is all about making a ketogenic diet healthy and accessible. Whether you're reading all of our online guides or articles or enjoying Perfect Keto's exogenous ketones or any other keto-friendly products, everything you need to make keto work for you is at perfectketo.com. I know what you're thinking. Hey, aren't you the founder of Perfect Keto? Yep, that's right. And all of my insanely high standards have been put into making each and every product. My background as a functional medicine clinician helps me craft the cleanest and healthiest possible products and the best information about the ketogenic diet. Head on over to perfectketo.com to learn anything you need to know about the ketogenic diet. And if you've never tried any of our products before, feel free to use the code KETOPODCAST for 20% off your first order. With that being said, let's get into the show. Doc, thank you for joining us today.
It's a pleasure to be here.
Before we go into some of probably a little bit more in-depth topics here, I just wanted to take a step back and chat about your background and what makes you so qualified in this topic.
Yeah, well, I'm a professor at Boston College. I've been here now for about 33 years. And before that, I was at Yale University Department of Neurology for 9 years. And I took that position as assistant postdoc and then assistant professor after having received my PhD from the University of Illinois in biochemical genetics. So we have done a lot of work in the field of epilepsy, in neurodegenerative diseases like lipid storage diseases, Tay-Sachs disease. And then, of course, we have been working on the issue of cancer metabolism and biochemistry parallel with all these other studies that we do.
Great. And so how did you go from studying epilepsy to cancer? Is it just something that sort of popped up as a big problem to solve, or like what was the path that led you to that focus?
Well, I mean, we had been studying cancer parallel with epilepsy, but for different fundamental reasons. Our work in cancer was mostly looking at the changes in cell surface carbohydrates related to the migration or invasion of tumor cells. Where the work on epilepsy we were in the process of mapping genes and looking at gene environmental interactions. The emerging of the two came when one of my students requested to attend a meeting in Seattle, Washington, on ketogenic diets for epilepsy. And I had been aware of ketogenic diets for epilepsy, for a long time. I mean, this is not a new field. It was started back in 1921 by Wilder at Mayo Clinic. But for the most part, people were not excited about ketogenic diets for anything until Jim Abrams and the Charlie Foundation. His son Charlie had seizures and almost died. And then there was a small group at Johns Hopkins University that are friends of mine, Jim Freeman, the late Jim Freeman, and his associates were working with ketogenic diets for epilepsy. And of course, we had one of the best epilepsy models in the mouse. So one of my students in a PhD project says, why don't we try to figure out how the ketogenic diet works if we could manage seizures in this particular mouse that we had. So I sent her out there and she met Jim Abrams, and this was like the beginning of the Charlie Foundation's organization. And then Meryl Streep had done the movie First Do No Harm, which was put on by Jim Abrams in honor of his son Charlie to try to bring the world attention to this. And when my student Mariana Totrodova came back to the lab, she said, "Oh, we have to do this ketogenic diet stuff in the epilepsy." And we didn't put it on the cancer models until we realized that a major way the ketogenic diet works is through calorie restriction. And we knew that calorie restriction could also reduce tumor growth. So we kind of merged the two together. We were first interested in what calorie restriction might do to the lipid profiles of the tumor cells, and then we began to realize that calorie restriction, just cutting back the amount of calories that the mouse ate, had powerful effects on the growth of the tumor. So we kind of shifted away from epilepsy. I mean, we spent a lot of time trying to figure out how ketogenic diets could manage epileptic seizures. So we were deep into the biochemical mechanisms, and we still really don't know to this day the exact mechanisms by which ketogenic diets can stop seizures. We just know that it's probably one of the most powerful ways to stop epileptic seizures. A lot of it has to do with the levels of glucose and the levels of ketones.
Do you have any leading theories as far as what you think the mechanism is?
Well, I think we don't really know because the neurons are and how they work electrically is a very complicated situation. We knew one thing, and we published a major paper to show that the therapeutic success of ketogenic diets for epilepsy were based largely on maintaining a lower stable glucose level. And we published this, and many of my friends in the epilepsy field began to very carefully monitor glucose levels in their clinical patient young people population. And they found that if you can keep blood sugars low and stable, seizures in most of the children were managed. But every now and then the child would grab a Coke or a piece of cake or bread or whatever, and it would send the sugar high, and they would have breakthrough seizures. Almost so you could manage a child for months, and then all of a sudden that child could have a breakthrough seizure within minutes, several minutes, a half an hour of having consumed some sugary drink or food. So clearly the long-term benefit was like wiped out immediately. And but then of course the child would bring the glucose down, and the seizures would be modified. And we did a lot of these basic research findings in the mouse. So we were quite aware of the role of sugar, glucose actually, and ketones. Was it the elevation of ketones, the lowering glucose? And of course, what are the neurochemical mechanisms involved? And that's still under very active investigation.
Has there been any research done where levels of ketones have been available in the bloodstream while a spike in glucose has been there?
Yeah, and that was one of the things that it didn't clear when the child took the drink, it didn't clear ketones out of the blood as quickly as the elevation in glucose. So you have insulin surge. You're under a low carbohydrate ketogenic diet, and you're extremely insulin sensitive. So when you take the sugar, insulin goes right up real quick, and that could be one of the participatory events in the breakthrough seizure. We're not really sure of all the details, but as I said, this is a very active area of investigation. But you didn't wipe out all the ketones. So, and this is what we came later to realize in cancer. The same, it takes a while for the body to flush out the ketones. I mean, it can happen over a period of hours, but generally the ketones are still present. So we were I wrote a big review article on the mechanisms by which ketogenic diets could stop seizures. And, we had been involved in a lot of this. So our background was clearly in how ketogenic diets might be managing epilepsy. And then, but, at the same time, we began to shift these same kinds of diets over to cancer. And the mechanism for managing cancer is so much more clear and understandable than it is for how this ketogenic metabolic therapy works for epilepsy. So the cancer becomes clearly a disease that can be effectively managed and actually prevented by this same mechanism that manages seizure. But the same approach the mechanisms are very different, but the approach is similar.
Right. So during your research, is that when you came to the conclusion and sort of planted your flag in the ground, wrote your book, Cancer is a Metabolic Disease, or did you have that viewpoint before you started this research?
No, I mean, we had not worked deeply in the cancer field as far as management. We were doing years of basic research on lipid biochemistry and cancer cells, which called basic research. What role do gangliosides play in the growth of the tumor? We weren't looking. We had some drugs that we're going. In fact, this is one of the main linkages, is that we found a drug that could block ganglioside biosynthesis and in the brains of Tay-Sachs disease mice. And in our cancer work, we showed that this same drug could really block ganglioside biosynthesis. So we said, whoa, this might be a connection. So we fed the mice this drug, and sure enough, the gangliosides in the tumors went down, but the tumors shrunk tremendously. So the company that was interested in this drug supported our research for $200,000 to do a pilot study on how this drug might be reducing the tumor growth. Was it through ganglioside? Was it through a biochemical mechanism or what? But then we found that this drug caused the mice to lose weight. As a matter of fact, the drug blocked the ability of the digestive system to metabolize food. So the food was kind of collecting in the gut of these mouse, in the stomach and the intestines. And the mice were actually getting an indirect calorie restriction. They were eating the food, but they couldn't digest it because the drug was blocking sucrases in the gut that are needed to break down digest food. So we didn't know at the time. We didn't know what was going on. And then I said, one of my colleagues said, let's put a control group in there. Let's restrict the food intake in these mice to match what the body weight reduction that the drug was causing. And it turned out that they both shrunk the tumor to the exact same degree. So the drug had nothing to do with any kind of a sexy biochemical mechanism. It was just causing the mice not to be able to digest the food they ate. So it was clear that the drug was working through an indirect calorie restriction.
Got it. And so at this point, moving over, is that when you sort of had the aha moment to start pulling the thread a little bit more here?
Yeah, well, then we said, what could be causing this? And we went back and we found that Otto Warburg had said a long time ago that, these cancer cells depend on glucose, and if you target glucose or try to do that, he was more interested in, how cancer cells were growing, and it turned out to be a glucose mediated mechanism. And when you do calorie restriction or therapeutic fasting, you're lowering blood sugar. And we were able to link this very, very carefully to show that there was a direct correlation between how much sugar was in the blood and how fast the tumors grew. And now we were the first to do this. That now has been established for all kinds of human cancers. As I said, most human cancers, if you want them to grow fast, you get your blood sugar up as high as you can. Insulin and sugar drive those tumors like crazy. And when you do calorie restriction or fasting, you lower insulin and blood sugar, and that's connected to a reduced rate of tumor growth. So you can see that, and then we began to look more into what Otto Warburg had actually said, and we looked at his papers in German and English, and we just went through the whole thing, and then we began to find that all of the things that he had defined were in fact correct. But most recently, we just published a paper with my colleague Christos Yiannopoulos from the Semmelweis University in Budapest, Hungary, showing that we've identified the missing link in Warburg's central theory, and that is they can also ferment amino acids, and especially glutamine. So the cancer cell is simply, now we know, is simply a fermenting cell, ferments, and if you target the two fermentable fuels, you can eliminate the tumor cells.
Okay. And so for people who aren't familiar with Otto Warburg and his work, how would you, maybe for somebody who doesn't really understand a lot or has maybe a concept that is ingrained in most people's heads that cancer is just a DNA damage thing. Once the DNA gets damaged, the cell proliferates indefinitely. So this is sort of a different way to look at it.
Well, it's, we have now shown through nuclear transfer experiments and all kinds of other things that the DNA damage is a downstream effect. It's not the cause. So we know that now, although, to be honest with you, that's a very, very difficult pill or piece of information to swallow on the part of a vast academic pharmaceutical industry that banked their whole existence onto this DNA information, which now we know is wrong, fundamentally wrong. Because the evidence that we have now to show that cancer is a mitochondrial metabolic disease is overwhelming for those that actually want to look at the research. The bottom line is that Otto Warburg was absolutely correct in defining cancer as a metabolic disease. The problem is he did not know about amino acid fermentation, and that's the missing link in Warburg's theory. And that missing link led to significant confusion for decades. And it was never clearly recognized because many of the enzymes in the systems were not identified during Warburg's time. So there was a lot of confusion about, whether it was purely glucose or something else, because people had found cancer cells that did not respond to glucose restriction. And they said, see, Otto Warburg must be wrong. And that led to confusion. And then, of course, when the genetic revolution occurred and they found all these broken chromosomes and mutations in the tumor cell DNA, everybody ran down that path in a herd. It's called groupthink. And then that was so exciting to see all these mutations in cancer cells, leading people to believe that that was the origin, when in fact now we have shown, and others, that it's all downstream epiphenomena. When you damage the respiration, they throw out all these reactive oxygen species, which lead to the damage of DNA. So the reactive oxygen species are carcinogenic and mutagenic. So consequently, everybody, so many people in the cancer field were simply studying effects rather than causes. And as the result of that endeavor, the results of that endeavor is that we have today 1,600 people a day in the United States die from cancer. And they're dying because the field is focusing on things that aren't relevant to the nature of the disease.
Right. And so it's sort of like if you had a fire in your house, but you had sprinklers that it was trying to put the fire out and your basement flooded. And so you say it's a problem with the leaky water line. Let's try to get these buckets out of here, and not understanding the fire and why it's there.
Yeah, I mean, I'm sure there's a lot of analogies and things that we can link to this whole problem. But and then of course we have the phenomenon of what we call escalating situations. Because we have invested so many hundreds of billions of dollars into this approach of cancer as a genetic disease, and the infrastructures that we've built in the major academic institutions and pharmaceutical companies, to say that effort is largely misplaced, despite we've just invested so much in this. We have to keep going. That's what we call an escalating situation. In other words, you throw good money after bad. And you keep doing that because you have already invested so much in this whole process. And then to realize that this is the wrong route, the wrong direction, the wrong road, is just too difficult for the majority of people working in the field to accept.
Right. And so just to break it down, if we didn't cover this very clearly for people who may not have picked this up, but the thought is that the cancer cell now is basically running on two different fuel sources and has a different fuel supply, and has different instructions from the cell. Now, what would be causing that? And what would be you said earlier, there's a way where we can have some prevention as well as treatment. What are the things that are causing this in the first place to get to this point?
Yeah, well, this was called the Oncogenic Paradox, actually first defined by Albert St. Georgi, a Nobel Prize winner back in 1979. That was his problem. He said, what is going on here? He says you can get cancer from so many different ways. Viral infection, systemic inflammation, radiation, carcinogens, chemicals that we are known to cause cancer. But there was no common linkage by any of these provocative agents, an underlying common link. And what we have done was we've shown that common link is damage to the mitochondria in a particular population of cells in a particular organ. So someone could be exposed to a chemical carcinogen, and that person may get, a liver cancer, where the same carcinogen might give somebody else a kidney cancer. The bottom line is the carcinogen is causing cancer by damaging mitochondria in some cells of an organ, and those cells then begin to ferment. So if the respiration is damaged by the chemical carcinogen, in order to stay alive, the cell must transition its energy from an oxidative state, breathing air and getting energy through oxidative phosphorylation, or ferment. And as Warburg said, if the insult is too acute, if it's too strong, cells die, and you can't get cancer cells from dead cells. So the damage to the respiration by a carcinogen or whatever has to be gradual, so that the cell has the capability of transitioning energy away from oxidative phosphorylation to fermentation. Now, fermentation metabolism existed on the planet before oxygen came into the atmosphere. So basically, these cancer cells are simply falling back on ancient pathways that existed before oxygen came into the atmosphere, and this is and they enter a default state, which is proliferation. So the mitochondria are such an important organelle. They keep the cell healthy, and they keep the cell in a differentiated, stable state. And when that organelle becomes damaged, the cells fall back on fermentation, and that leads them to proliferate just as they did before oxygen came into the atmosphere. All cells on the planet were highly proliferative, using a fermentation metabolism before oxygen came into the atmosphere some 2.5 billion years ago. So basically, the cancer cell is simply falling back on these ancient metabolic pathways, and the results are unbridled proliferation. And if you pull the plug on the fermentable fuels, which are primarily glucose and glutamine, the cells die.
Right.
So the whole system becomes not that complicated.
And so obviously this is, there's two separate conversations that I think someone can have when they're thinking about this type of stuff. One is treatment, and I think that you've done a lot of work in that arena. But another one is maybe just asking the question, then if mitochondrial dysfunction is what leads this in the first place, what have we done in this field as far as researching mitochondrial health and how to promote it?
We've done very little. We all know that if we diet and exercise and don't smoke and don't drink and all this kind of stuff, I mean, we're supposed to get a lot healthier. We reduce risks, but we don't. We live in a risky environment. All of us, every one of us on the planet, we live in a risky environment, and we make decisions about things. And as I've written in my book, significantly reduce the risk of cancer, you reduce risk of damage to your mitochondria. Now, sometimes we can do that. I'm not sure if, viral infections, hepatitis C virus and papillomaviruses and these things, they enter your body and they damage mitochondria, and you can get liver cancer or different kinds of cancers from viral infections. And but again, it comes through the mitochondria. So if you can avoid viral infections, you can avoid cancers caused by viruses. If you avoid being exposed to radiation, you can avoid the damage that radiation would do to mitochondria in a particular population of cells. If you can avoid systemic inflammation, all right. So there's a link between obesity and inflammation and cancer. I mean, this is very clear. People know about this. So you'd say, well, how do I reduce systemic inflammation? Well, you reduce blood sugar. Blood sugar sustains inflammation, and inflammation can damage respiration in a population of cells. We can go down through the entire list. Now, one thing we can't really do too much about is age, and cancer is more prominent in older people than younger people. And just being on the planet for many decades puts you at risk for damage to respiration in a particular population of cells. But there are ways that you can enhance the function of your mitochondria, and that's one of them is burning ketones. So how do you burn ketones? Well, you go under fasting, or you take low carbohydrate diets. All that will reduce risk to damage to mitochondria.
Right.
It's just this personal choice.
And I think it's so confusing for so many people because this is not an area of health that we typically focus on. There are so many things that can affect it, and there are no ways to assess it really. I mean, there's some fringe ways you can kind of approximate mitochondrial function, but there's not really any it's not you can go in people try to get blood work and it says, oh, your mitochondria are functioning, X%.
Yeah, but you can use the glucose ketone index to get it as a biomarker to know whether or not whether your mitochondria are going to be burning ketones or not. And that's what we published a paper on that.
Okay.
So
And so can you explain? So for people who don't understand glucose ketone index, it's basically just a very easy proxy where you divide glucose by ketones. So you're saying that this is sort of a way to approximate mitochondrial function and not just metabolism and what fuel sources you're using?
yeah, it's an indirect way because we know that when mitochondria burn ketones, the amount of reactive oxygen species that they produce is significantly lower. And we also get more what we call energetic bang for the buck. And this was all worked out in a very sophisticated biochemical procedures by Richard Veitch at the National Institutes of Health and a number of other individuals. But when mitochondria burn ketones, they get healthy. And they get healthy because they're more energetic and they produce fewer of these reactive oxygen species during their metabolism. So that in itself basically delays entropy, the second law of thermodynamics, which is disorder. So by burning ketones, you reduce metabolic disorder and therefore keep the system at a higher rate of efficiency. And you can use the glucose ketone index as a means to know this. So, and a number of people are on the web, looking at their GK, we call it the GKI. So if you have a GKI, glucose ketone index, so you simply measure, there's meters now that are available from Precision Extra and Keto Mojo that you can buy them through Amazon. And they give you, one strip will tell you what the glucose is, and another strip will tell you what the ketones are. And of course, the glucose comes in the form of milligrams per deciliter, whereas the ketones come in millimolar. People say, wow, what's going on? Well, you have to make a division and bring them both to millimolar, and then you can get the ratio. But there's actually
dividing the glucose by 18, roughly.
Yes. It's it's so simple, but some people get flustered. Keto Mojo just built a meter now, which converts the glucose into a GKI right away. So you just push the button and you get your number. And so that makes the division, you don't even need to divide by 18 anymore for glucose. So you can just push the button and you can get your GKI. And people are challenged. They say, hey, wow, how healthy can you get? Let me see what your GKI is. Or you can do it by therapeutic fasting. You just stop eating. It's not easy. Believe me, I'm not sitting here telling people, hey, just go out. But that's the best way to get your blood sugar down and your ketones up. As a species, we evolved to starve. Our existence on this planet was because we could go long periods of time without food. We evolved in a very food restricted environment, unlike what we have today. And we have all these, these degenerative diseases linked to the abundance of poorly nutritious, high carbohydrate foods. It's killing and making so many of us sick. But, we didn't evolve in that kind of an atmosphere. We always had low GKIs through our evolutionary past.
Got it.
But now some people say, well, I want to go back to the old days, the ancient period. How would I get my what would I need to do? Well, you can avoid, carbohydrate foods, and you can bring your sugars down and your ketones up with exercise. And then you measure your GKI, and we said if you could get it near 1.0, you're really in therapeutic ketosis. And that state will keep your mitochondria very healthy. And that will reduce significantly your risk for not only cancer, but, other chronic diseases, cardiovascular disease, type 2 diabetes. You can cure type 2 diabetes with metabolic therapy. You don't need any drugs.
Right.
So they just have to bite the bullet on personal discipline.
So for example, for when people, I talk to a lot of people about this type of stuff, and I think a lot of your research shows that a lot of the therapy, like you said, is around 1.0. And I see a lot of people when they start a ketogenic diet, they have their ketones ramp up, but then as they become more efficient at burning them, it goes out of their bloodstream and the ketones go into their cells and actually are utilized for energy more. So is there sort of a proxy for when people dip off of that and go down? So for instance, like if I've been on a ketogenic diet and working out, doing a lot of strength training, especially for months at a time, my millimolar of BHB in my blood is roughly 0.8 to 1. Whereas if I am switching back and forth in and out of ketosis often, going back in, my levels would be higher because my body's not used to using that as energy. Is there any sort of proxy there that you've seen or change over time with people get actually keto adapted?
Yeah, well, that's certainly the case. my colleague Dom D'Agostino is always experimenting with these kinds of situations, and he's pretty much in ketosis all the time, but it can up and down like you've indicated. It can vary, but your body does become adapted and becomes much more energetically efficient. Cells just over time, it's like getting in shape. So you always say, well, I got to run a marathon. Well, I got to get in shape. Well, if you're going to do, therapeutic ketosis, it takes time. It takes time for the body to readjust to these new physiological states. But at least you have the GKI as kind of a biomarker to let you know where you were and where you need to go.
Got it. It's more of a trend than an absolute number. So I'm just assuming people, maybe they're hearing this and they say, oh man, I want to prevent cancer as much as possible. I want to get my GKI to 1. I mean, is this the best thing that they can focus on?
Well, I think it's the easiest thing they can focus on. It also is a challenge. And they also know how difficult it might be. Just like someone would say, I think I want to run a marathon, a Boston Marathon. Well, you're not just going to go out without practice and just run the marathon. You're going to be really dragging. So, but I think with some degree of practice, you can get your GKIs down into these zones. You find the foods that will maintain low carbs into your body, and your body gradually starts to pick up the ketosis. I just want to point out though that for normal healthy folks, you can get into these zones pretty easily. I don't want to say easy. You can get into these zones with not extreme difficulty. The cancer patient, on the other hand, has far greater difficulty getting into these zones than normal healthy people. And a lot of that has to do what we found with anxiety, fear factors, some of the treatments they're on, and all these kinds of things. It keeps glucose high. You'd be stressed. Emotional stress keeps blood sugar high. It's so hard for the cancer patients to get into these so-called really healthy therapeutic ketosis zones, especially if they're being treated with radiation and chemo and these kinds of things. It really puts so much stress on the body. It becomes a Herculean effort to get into these healthy states. Not that they can't. It's just that it requires far more persistence and effort than it would be for a healthy person.
Yeah, I mean, I haven't even thought about that condition much. I wear a continuous blood glucose monitor pretty often, and even when I'm stressed at work, my average can jump by 20 points for a whole day or 2 days. And so, and that's just me working. That's not me grappling with the fact that I have cancer and I don't know what to do, and I'm under all this physical stress as well. And then so kind of bridging the gap here, talking about setting the stage for prevention is just treating your mitochondria right, keeping that healthy. It's an entirely different discussion. A huge problem that you're focusing on as well is the treatment. And okay, now let's say you do have some of these mitochondria that have now transitioned over a long period of time into cancerous cells that are proliferating. The question then is, what do we do to stop this proliferation? And so at this point, probably how you would describe it, and correct me if I'm off base here, is that we have to look at the fuel system. So how is this mass growing? How is it moving? Well, obviously you need energy input to have an output of growth, right? And so you're saying that, Warburg showed that glucose in was a big fuel source, but we were sort of missing something. And now you're saying that glutamine is another way that we can use this and ferment glutamine itself as far as pushing the growth forward. And yeah, is this where you're at?
Yeah, that's exactly where we're at. So we just published a big paper in Communications Biology, my chief associate, Dr. Purna Mukherjee, where we targeted simultaneously glucose and glutamine. You need drugs to target glutamine because it's not you can't manage it effectively with diet.
So actually, before we dip into those new findings, when people now are on ketogenic diet, I think they understand that your blood glucose doesn't drop to zero. Your GKI doesn't go to infinity. And so the question at that point is that, are you going to have, through a bunch of different processes in your body, gluconeogenesis and others, you're going to have some glucose around, but that doesn't go to zero. So the concern to have glucose as a fuel, is this why, for instance, resistance training is so great when undergoing treatment of cancer, because it's sort of upregulates the GLUT4 transporters and creates a glucose sink and pulls it away from the cancer cells? Or how do we shift the balance of fuel?
Yeah. We published that. Yeah, I showed that because when you start to reduce the sugar for the body, normal cells compete now directly with the cancer cells. So you're using your normal cells as part of the solution to the problem. For the first time, you're asking normal cells of your body to come together and upregulate glucose. Because we did that. We put mice on some of these very restricted glucose conditions, and we saw elevation of glucose transporters in the normal cells go up when we significantly real. So that means they're in direct competition with the tumor cell. The normal cells can burn either ketones or glucose. The tumor cell can only burn the glucose. So you're competing. The normal cells are competing for the fuel that will keep the tumor cells alive. But the normal cells can also burn the ketones, so they can stay alive using either glucose or ketones.
So would you in that sense though want the ketones a little bit lower, so that way your body puts to use and outcompetes the cancer cells for glucose?
Well, these are very good questions, and this is where the cutting edge is right now when I'm working with my clinician colleagues in translating the information that we have from the research in the lab with the animals, and how we transition these different strategies to people. And, how low should you push your blood sugar? How high should you push your ketones? For how long? We don't only use this. Let me start by saying the first thing we would like to do in the clinic when someone would be diagnosed with any kind of a cancer is we do a comprehensive blood work, because it turns out that many people with cancer also have many other metabolic imbalances. It's unbelievable. So if you look at their blood work, a lot of things are out of whack. LDL, HDL, triglycerides. You can have C-reactive protein, ferritin levels. All these different kinds of levels are indicators of overall health status, and and many times, not always, but we see some cancer patients are all out of whack with these biomarkers. So biomarkers of health, of course. So we have to know where the individual is before where we know to where we are going. So as we first transition this individual off the high sugar and all this other stuff, he brings the whole body into a new state of health. Now that already will shrink tumors, and that will already slow down cancer growth. Once we get the person into therapeutic ketosis, then we begin to go after the glutamine, and we begin to put maximum metabolic stress on the tumor. That's why we use hyperbaric oxygen. My colleague Dom D'Agostino was really big on this. We can kill tumor cells using excessive oxidative stress rather than radiation. So once you pull away the fermentable fuels that protect the tumor cell from radiation and chemo, now they become extremely vulnerable to oxidative stress created by hyperbaric oxygen.
Okay, and so would you, for instance, do like a 3-day fast going into that, and then go aggressive at the end of the fast with hyperbaric oxygen? Or like, what is the protocol?
Well, what we think the protocol will be is what we do is we transition the patient first off to a low carbohydrate diet before we do therapeutic fasting. It's the transition from a low carb diet or a ketogenic diet into water-only therapeutic fasting. The transition is much easier than going the reverse. There's going cold turkey on the food. It's very, very hard.
Yeah, it's brutal.
After 3 days, man, you're ready to chew paint. It's not easy. So, but the transition going from saying, okay, well, I'm eating a balanced, carbohydrate diet and whatever. So you gradually reduce the carbs to almost as low as you possibly can get for maybe a week or more. And then you can see the blood sugar going down and the ketones going up. So the person is naturally going into a state of therapeutic ketosis. And then you can do a water-only fast for a few days. And it becomes far, far less stressful on the body. Then once the person is in this good state of therapeutic ketosis, then we can start hammering the glutamine. We use drugs for that, and hyperbaric oxygen. And the goal, of course, is to gradually degrade the tumor slowly while maintaining a high health status of the body and an overall quality of life. So at no time should this patient have to suffer any kind of a very toxic approach. There's like we're eliminating the toxic effects, and we're keeping these people very healthy, and we want these people to emerge from the treatment far healthier than when they started, not like death warmed over like you see today with the treatments they're giving these poor people. So the goal is to stop the proliferation of cells that are fundamentally fermenting, and we don't need radiation or chemo toxic chemo to do that. We just have to know how to pull the strings on the metabolism of the cell, but you have to do it gradually so you don't cause any harm or toxicity to the.
Okay, so you're saying, okay, so we have glucose and glutamine. So glucose, we talked about, strength training can pull some stuff in there, switching to a low carbohydrate diet. And then anything else that you would recommend as far as lifestyle changes that could help balance the glucose from the cancer cells to the rest of the body?
Well, I mean, I think we use the ambiguity here comes when people say, "Can I eat this? Can I do that? Can I do this?" And everybody has a different story because we're all physiologically a little bit different from each other. And we use the GKI indexes to let people know. It's like some guy can eat something and it really throws the index out of whack, and another guy can eat the same thing, it doesn't do anything.
Right.
So every individual is unique, and they have to have their own meter. They look at their own data and they share that with their healthcare provider that understands what's going on. And Miriam Kalamian, who you said you interviewed, she's helped so many cancer patients, maintain in the so-called therapeutic zone. And and we're developing the kinds of drugs that would work together with the metabolic state to destroy these tumor cells. So it's not just one approach. What we have here, we have entire metabolic reconfiguration of the body that will involve dietary changes used together with procedures and drugs that target and kill the tumor cells in a non-toxic way. And we are absolutely convinced that this works. We've seen it work in many, many different patients with all kinds of different cancers. In fact, as I said, cancer is a singular disease. It's not 100 diseases. If you have bladder cancer, colon cancer, brain cancer, breast cancer, the cells are all fermenting, and the most abundant fuels are glucose and glutamine. So the strategy to kill cancer is not that complicated. And many people simply can't believe that because of the enormous investment we have made in the approaches that we're using today, making it seem like it's infinitely complicated. And it is when you look at it from a genetic perspective, but when you look at it from a metabolic perspective, it's a very simple disease. So
the recent thought you had about glutamine being a fuel source here, is it something that the cancer cell would prefer glucose, and then once you start taking that away with low carbohydrate diets and all these other things we talked about, then it starts hedging more towards glutamine as a more readily available fuel source? Or how does it choose, or is it sort of an ambiguous process?
No, it's first of all, the cancer cell doesn't prefer anything. It just uses what's available in the microenvironment to fuel the fermentation, because without fermentation, it's dead. So, and as a matter of fact, it just comes down to basic energy. Without energy, nothing can live. So every cell acquires energy through the process of metabolism. You either get it from glucose through oxidative phosphorylation in normal cells, and the waste products, of course, are water and CO2 in normal cells. The cancer cells, they can't use that part of their metabolism, has been corrupted by any number of means, as I mentioned to you already. Any number of things can corrupt the ability of the mitochondria to get energy through oxphos. So what does that leave them to get? How are they going to survive and grow without energy? They need energy, and that energy comes from glucose and glutamine. And there are some cancers where you can pull away all the glucose and they still thrive, and they're thriving on the glutamine. And there are some cancers that use mostly glucose, but the majority of cancers use both, only because glutamine and glucose are the two most abundant fuels in the tumor microenvironment. I mean, there are other amino acids in the environment that can fuel a cancer cell. The problem is there's much less logistics. It's a logistics supply issue. So if I'm going to run an inefficient metabolism, I better have a large amount of fuel available to run this inefficient metabolism, because it's not efficient. Therefore, there's a logistic issue. Where am I going to get the fuel to run an inefficient system? And the answer is the fuel is readily available. As a matter of fact, we just published a paper showing in brain cancer how the radiation and chemo of people with brain cancer free up massive amounts of glutamine and glucose in the microenvironment, which ultimately leads to the rapid demise of these poor people. In other words, the very therapies that are being used to treat glioblastoma are contributing to the death of the patients, not only just the tumor, the very treatments themselves. And this can explain in large part why so few people survive. They survive because the very treatments are freeing up massive amounts of glucose and glutamine. So the tumors are always going to be growing. So, I mean, and this explains, it was a very big paper we just published on this whole thing.
And so I think that a lot of people might not understand. So they think glutamine meal, though, they have some connection to food or nutrition. I think, okay, I'll just stop eating protein that contains glutamine. Not that simple, I would assume.
Yeah, no, it's not that simple. The body can make glutamine from other, that's why it's called a non-essential, because the body can make it from things. Our muscles are loaded with glutamine. Part of the cachexia that people get, loss of weight, despite the fact that they might be eating, is the muscles release glutamine into the microenvironment, and this can find its way to the cancer. So you need a drug. We need specific drugs. We've shown that this glutamine antagonist, 6-diazonorleucine, which is called DON, really does a good job in depriving the cells of glutamine. But it works so much better under therapeutic ketosis. So therapeutic ketosis not only works together with the drugs, but it also facilitates drug to target. And so there's a lot of things that we need to know, but the basic outline and the basic framework is in place. And I think it's going to take time before the oncology field recognizes, number one, cancer is not a genetic disease, it's a metabolic disease. And number two, how best do we treat patients using this new paradigm? And this is obviously going to take some time. But once people understand it and they realize how powerful it is and how effective it is, I think it's just common sense that this is going to happen.
Right. So obviously the non-essential glutamine is from, so your body can make it, but still your body needs it. So would you just pop this drug in there every now and then to do sort of a targeted approach to it, to not deprive the body completely of glutamine and block all of its reception, or how do you?
No, you're 100% right. This is what we call in our big paper we published called Press Pulse, a novel strategy, which is exactly what you just said. We're still in the, as I said, we understand the framework, we understand the concepts. We just have to work dosage, timing, and scheduling. You're absolutely right. Glutamine is such an important amino acid. It runs our gut. It runs our immune system. It runs the urea cycles. I mean, we have a lot of physiological things going on that require glutamine. So we just can't go in there like a bull in the china shop and just rip out all the glutamine, because you're going to harm the body. So it has to be done strategically. It has to be pulsed and used under certain conditions in certain ways. And this is what we're working on right now. This is what people say, well, this is not sexy science. No, it's not. It's not sexy science, but it will actually resolve the disease if done correctly. So, and I think that's the ultimate goal. Isn't the ultimate goal to resolve the disease without toxicity? Right. The issue is doses, timing, and scheduling. And this is the cutting edge right now. And once we've figured this out on the preclinical systems, we can then immediately translate this into the clinic. We're doing that now in patients, but with my colleagues in different countries. But we're still not there with respect to the issues that you just rose. These are very important issues that need to be worked out. But we can do this. This is not an insurmountable problem.
Right. And so is this sort of a mechanism, the glutamine production, that why people say that, or it's commonly held that you should reduce a lot of protein consumption when you're doing any sort of cancer treatment, regardless of chemotherapy or not? Or are there other mechanisms here that we don't want to fuel cancer growth through that? Or can they pretty much only, as a fuel source, be using glucose or glutamine?
Yeah, no, this is an important issue, because T. Colin Campbell had published some interesting papers in rat tumors where protein content under a certain level was therapeutic, but when you reached a certain threshold where it went over, it could stimulate tumor growth. And you have to realize that many of these proteins are broken down and to glucose. They're fuel for gluconeogenesis. So you can take the carbon structure of protein, break it down to amino acids, and produce glucose from that. So I'm still not sure yet whether taking glutamine as part of the diet, because a lot of cancer. Interesting enough, a lot of cancer patients are so beat up by the toxic therapies, they take high dose glutamine to recover their gut function, and we're not yet sure whether that's going to be provocative to any surviving tumor cell. And it's another interesting thing. You can do hyperbaric oxygen insurance companies cover hyperbaric oxygen to recover the damage from excessive radiation to the body, but they will not cover hyperbaric oxygen to actually kill tumor cells. It's kind of a crazy system.
I'd be interested to see, for instance, if the argument is that reduce protein intake so that way you don't have supply of glutamine or even glucose through gluconeogenesis and all these other factors. How much does your body release into your bloodstream when your cachexia can start losing muscle mass? And then,
good point. We know a lot of that goes to the tumor cells, and that's what the tumor cells are sucking out that's why you're cachexia. Cachexia is weight loss because of a pathological situation. The tumor is using energy from the body to grow at the expense of muscle and other tissues. So and as a matter of fact, blood sugar and insulin are high under cachexia. Can you believe this? Now, under therapeutic ketosis, when you stop eating or when you're doing these calorie-restricted ketogenic diets, insulin and blood sugar go way down. So that's what we call therapeutic body weight loss. It's a therapeutic state, whereas cachexia is a pathological state. So people, have to realize body weight loss can be very therapeutic in one context, but very pathological in another. And of course, many cancer patients, unfortunately, are poisoned and irradiated. And when I say poison, the drugs that they use, these chemotherapeutic drugs, are actually poisons. They poison the body. They kill tumor cells too, but they poison your body. And of course you lose weight. I mean, you're sick, you're vomiting, you have diarrhea. These are all indirect forms of calorie restriction, but you're causing harm to the body, and the weight loss is pathological. This is very different than therapeutic weight loss. So people have to get over this idea that weight loss is always bad. Weight loss can be powerfully therapeutic when done under the right context. So all of these things have to be adjusted. And getting back to the two fuels, glucose and glutamine. A lot of people, many people have said, oh no, cancer cells can burn fat. So in order to burn fat, you have to have healthy mitochondria. Mitochondria are beta oxidized, fats are beta oxidized in the mitochondria, and they generate energy through oxidative phosphorylation. But people say, well, I know cancer cells burn fat because I gave a lot of fat to the animal and the tumors grew faster, or people. And I said, well, there's also a lot of glucose you have around, and there's evidence to show clearly that high-fat diets, fat itself can force the tumor to take in more glucose and glutamine through alternative mechanisms. So it appears that the fats are making the tumor grow faster, but if you have a significant amount of glucose and glutamine, the fat will make the tumor use more glucose and glutamine, but not directly. So people have to realize the tumor cells can only burn glucose and glutamine. And we went through this in a big paper and showed that any other amino acid, you have to invest energy to get energy, whereas glutamine is pure gold energy for that cell. You don't have to metabolize anything. It just goes right through the glutaminolysis pathway and generates massive energy inside the mitochondria through a fermentation mechanism. So you shut the door on the glutamine and you shut the door on the glucose, most of those cells up and die very quickly. So, and the normal cells get very healthy. So this is the strategy. And as you mentioned, if you do it right and you do it with the right dosage, timing, and scheduling, you can degrade and demolish these tumor cells quite effectively without harming the rest of the body. And people want things like this.
Right. And so to that point you just made, would you recommend only a calorie-restricted ketogenic diet? Certainly not a one with calorie surpluses.
Yeah, well, we found in both the epilepsy, it was very interesting. Years ago, John Freeman, the late John Freeman, the one of the founders of the whole ketogenic diet for epilepsy thing, he told me, we had a conversation one day, and he said, Tom, whenever we find a kid who really likes ketogenic diets, we can't manage his seizures. It doesn't work. So I found that to be a very interesting observation. One out of 400 kids just loves to pour keto oil all over everything, and he's got massive amounts. So we did it in the mouse. We gave mice as much keto as they could have, and we found they got insulin insensitivity and high blood sugar. So clearly, too much of this stuff is, again, it's a medicine. It's like any medicine. If you don't use it correctly, you can have effects that are not quite as the approach is not quite as effective. So most people, humans, they're not interested in eating massive amounts of ketogenic diet because the high fat in their blood triggers the eighth cranial nerve, which controls your appetite. So your appetite gets reduced. So overall, you're not consuming as much as you normally do. And some mice have this, some mice don't. So we always recommend calorie-restricted ketogenic diet. As long as you can get into therapeutic ketosis, you should be okay. But again, if you eat too much of this, you get insulin insensitivity and high blood sugar, which can then contribute to the tumor growth. So again, we're working out these protocols now that will be adapted for cancer patients, and it makes things a little bit easier if we can follow the pathway for ideal body metabolism. So it's a work in progress.
So an interesting question that I have is that you mentioned before how people can, for instance, in the seizure pathway, that as soon as they drink a Coke or eat a slice of pizza, they then have a seizure again, and it's not a complete fix in this stuff. As far as these cancerous cells, let's say you're doing this press pulse therapy for a long time, it shows that you're totally good, everything, complete remission, and then you drink a soda or eat a pizza. Is everything going to come flaring back again in the same sort of parallel to epilepsy?
No, it will not. And also there's several reasons. So you have to realize most of the people that are taking ketogenic diets for epilepsy are children, and the parents are the overseers, and they are rigidly compliant. Why? Because no one wants to see their child going through an epileptic seizure. It's a traumatic kind of event for the child and for everyone in the room. So the parents know they keep those kids really compliant so they don't have to watch their child have a seizure. In cancer, you don't see that at all. You can't see a group of cells growing because you decided to have a Coke. You don't see the same visual effects of that in some internal tissue or organ. So you don't really know, but we think that it doesn't nearly happen as quickly. You can't grow a whole bunch of cells real quick, like you can have what they call a breakthrough seizure, which is obvious. So no, we don't. We have patients that are people that are compliant. And every now and then they might have a pizza with water or a pizza with red wine. There's certain alcoholic drinks that don't raise blood sugar. So, but if people want to stay alive, they want to get control of their tumor, and they want to get control of their life. They pretty maintain. But I have to be honest with you, the human nature is amazing. We have people that tell us, "Oh yeah, I'm really, really compliant. I'm really, really," and then we look at their blood work and it's out of whack. There's no way they could be compliant. So what they do is they lie. They lie to themselves and they lie to others just so to make somebody say, "Oh yeah, you're doing a good job." So, but when you're dealing with a glioblastoma or advanced lung cancer, I mean, there's not much wiggle room here. I mean, you want to stay alive, you got to kill those tumor cells. You got to be compliant. Right. And compliance is a problem for any kind of a medicine. I mean, there's a lot of people taking radiation and chemo that aren't compliant either. So compliance always represents a challenge if you really want to get complete control over the disease you're working with.
Right. So, I mean, you found this DAWN to be effective at dealing with the glutamine pathway. I mean, are you guys adding in stuff like dichloroacetate or 3-bromopyruvate or anything like that to modify even more the glucose pathway with the pyruvate modifications? Or
yeah, I think these are possibilities. I mean, it's as scientists we have to be very careful about how we mix and match the drugs, just like you would do for any particular approach. Which drug, and we got to be careful because if we do it too aggressively, we get again harm body because you start screwing with too many systems simultaneously. So we're trying to work in very low doses of these kinds of drugs to work synergistically with the diet status. As I said, this is the cutting edge. This is where we need to be supported in doing these kinds of things, because ultimately what we're doing is defining the new protocol for cancer management. And yes, I mean, we can use supplementary drugs and procedures that would work together to further reduce glucose or the metabolic pathways that are involved. But, we have to do this very, very carefully, again, to avoid any kind of a damage or impediment of the entire process. And most of this is basically trial and error. That's why we call it people refer to it as non-sexy science, only because a lot of it involves trial and error. But ultimately, the end result is that you will have a protocol that will be effective in managing the majority of cancers without toxicity. And I think there's a certain motivation to want to do that.
So if somebody's listening to this podcast, has cancer, wants to be treated in this way and not go through the ringer like they have been, I'm sure they go to their primary care physician or oncologist and explain this to them, and they'll think they're a psychopath. Like, is your clinic the only one that's doing this type of stuff, or where should people go, or what should they do?
First of all, I don't have a clinic.
They said at the clinic that
I'm a professor at Boston College,
right.
So we don't even have a medical school here. But we work with people like in Istanbul, Turkey, where they were the first major group to embrace the concept of metabolic therapy from the book that I wrote. And they're getting rather remarkable success on using combinations of chemo drugs at low doses with hypothermia, hyperbaric oxygen, restricted ketogenic diets, the whole thing. And the patients are doing, in general, they're doing far better than most of the other clinics. Yeah, what you touched upon is probably one of the most difficult situations and frustrating situations. And that is, people listen to what I have to say or what some of my colleagues have to say, and they run down to their top medical school and their oncologists, and they say, well, this can't be right because I would have learned it in medical school. And no, they're not would have learned. It's not their fault. They've just simply were never trained to understand that cancer is a metabolic disease. They were not trained to understand Otto Warburg's central concept. And therefore, the very people that are supposed to provide the service to the patient are clueless as to the why we're doing this in the first place. And they're all fear and weight loss. It's the training of the physicians that needs to change. And I feel bad for all these cancer patients because they're running to they get discouraged and told that this doesn't work. What doesn't work? Where's the evidence? I'll show you papers that it does work. But they just don't read the literature. They're not on top of the scientific literature. I mean, a lot of people continue to treat patients with Avastin. Now, Avastin was pulled off the market. It's an anti-angiogenic drug, and it was pulled off the market for breast cancer because it didn't work and it was harming people. And, they still give it to brain cancer patients and other patients with other cancers. And we know that the tumor cell that will kill you doesn't care about angiogenesis and will grow faster with Avastin. Yet they continue to give people Avastin, and they don't read the scientific literature. It's very frustrating to see what we're doing to all these cancer patients based on a fundamental lack of knowledge on the biology of the very disease that we're treating. So I don't know. It's going to take a time for this whole thing to pass. I mean, immunotherapies, they work great on some people. But they don't work, and they could kill other people faster than the disease itself. Okay. But it's based on the gene theory. So when you say to the oncologist, are you giving me a treatment based on the metabolic theory of cancer or the genetic theory of cancer? They should give you an honest answer. And if they can't, then you have to say, well, what is this guy treating me for if he doesn't understand the biology of the problem?
Right. Do you have any rogue oncologists in the U.S. that you know of, or do you have like a list you're keeping there somewhere?
It's something we can't discuss because if physicians don't follow the standard of care, they can lose their license, and therefore there's a tremendous frustration on the part of the physicians who actually understand the concepts but are not able to administer this for fear that they'll be treating patients with therapies that are not sanctioned. I just came back from Switzerland where we had a big meeting on metabolic therapies for all kinds of diseases, including cancer. And one of my physician friends treated a woman with stage 4 metastatic breast cancer with metabolic therapy, and she did remarkably well. I mean, this tumor shrunk. She was very healthy. 3 years out, she's doing really well. And he was excited to present this to the oncology group in Switzerland. He was vilified. Because he didn't follow the standard of care, but the patient is doing remarkably well. The fact that the patient was doing remarkably well was inconsequential to the fact that he chose to treat someone with a non-sanctioned procedure. Wow. And had anything gone wrong, he would have been thrown in jail. So not the fact that this woman is doing really well, but the fact that he didn't follow the instructions. So it's okay for people to die through an officially sanctioned procedure than rather to save the patient's life through an alternative procedure. Can you believe this?
It's crazy. So what, if you were to diagnose the cancer tomorrow, would you just go to Istanbul and work at that clinic, or what would be your approach?
Well, of course, we developed a lot of the things. And even though we did this, I still like to consult with a physician that knows, the in and outs of actually treating somebody. I would know the concepts. I certainly, would follow what we've said. But nevertheless, I would still like to talk to someone who would be, we don't want to go out and everybody just treat themselves. You got to have a professional that understands the situation and can make recommendations that you in your present state may not have thought about. And I think that's always, I know exactly what I should do if I were to get cancer, but I still need a professional to talk about what I plan to do, just so I would talk about with him, and if something went this way or that way, we would have a conversation about what direction should we go in. Now, I understand that the majority of people who might have cancer need to rely on their caregiver with 100% confidence. And for many diseases and many situations, that's absolutely essential. But when it comes to cancer, we have 1,600 people a day dying. And in China is 8,000 people a day dying. So clearly we have an unrecognized epidemic of people dying from cancer. So obviously there's some serious problem in the entire system that needs to be changed radically.
So, I mean, it sounds like you're getting a lot of physicians that are coming to you and saying, hey, I really want to do this, or I've tried it out and it's working. They can't expand their scope or be very vocal about it.
Yeah, well, sometimes they can, sometimes they can't. But you're absolutely right. We're trying to work on a global society for metabolic therapy with physicians that are being trained as quickly as possible, and trying to establish an alternative standard of care based on solid concepts of metabolic approaches. But the issue, of course, is that we have to have a very powerful training session. We need to develop a protocol that's going to be adapted by the majority of oncology clinics, and that are going to be utilized for the majority of cancer patients. So there's a whole infrastructural system that needs to be put into place. But you're 100% correct. Most physicians have an intrinsic desire to heal and help their patients. And I think when they see the power of what metabolic therapy can do, they get so excited about this. And this is truly the art of practicing medicine, because you can tweak things here and there and make the patient actually come into a better physiological state. And this is what physicians do. Rather than what we do today is we just, sit people down and inject them with a certain dosage of poison that's strong enough to kill tumor, but not kill the patient. And or just irradiate some part of their body, one size fits all, and that's got to be history in the future, because we can't continue to what we've been doing. It doesn't work for many people, and I'm not saying that standards of care today are completely ineffectual. They are. Many people are walking around today, they're so-called cancer survivors, but many, or if not most, of those people have paid a serious price for their new state of remission. Their bodies have been beat to hell by radiation and toxic poisons. They now have all other kinds of health issues that they didn't have, but for the fact that they survived poison and radiation or some other kinds of toxic approach. So people pay a price for their survival. And we think we can manage this whole disease quite effectively without toxicity if we apply the right strategies, dosage, and timing with these metabolic therapies.
Yeah. Sounds like there's a lot of work to do, Tom.
Yeah, well, I mean, we're on the right path. There's a lot of work to be done, but there's more work to be done in the infrastructural and approach than it is in the scientific approach.
Interesting. Well, a lot of solutions out there. Thanks for taking the time. I really, really appreciate it. Where can folks find your work and maybe where you're active online?
Well, we publish most of our papers in open access journals. Also on the CrossFit website, I've put in I've been requested to put in some major discussions about cancer as a metabolic disease. So the CrossFit, if you can go on there and see stuff on cancer. But most of our papers are published in open access journals. People go online and see this. And if anybody would like to support the work that we do, Travis Christofferson, who published Tripping Over the Truth, a very excellent book on the cancer metabolic issue. He has a foundation called the Foundation for Metabolic Therapies, and that money is donated to Boston College through a grant system at the university. So that supports our research. Individuals donate to Travis's foundation, and then the foundation, because I'll be honest with you, it's very, very difficult to get funding for things that actually can resolve the disease. But if you can get millions and millions of dollars to study gene signaling pathways related to the disease, or something that may not have direct clinical relevance, you get a lot of money for those kinds of things. But actually trying to resolve cancer, very hard to get money, especially if it doesn't involve some toxic drug or some immunotherapy or something like this. So to let people know that, you have an idea, but, to get that idea fleshed out, it requires funds, and funding this kind of stuff has been very, very difficult.
Well, thanks for doing all the work you do.
Yeah, thank you.
All right, everyone. Thanks for listening to another episode of the Keto Answers podcast. I hope you enjoyed it, but even if you didn't, I would love a review. Just go over to iTunes, wherever you listen to your podcasts, and pop in a review so we can get found by more people, get better guests, and have the information that you need. So please go to iTunes, wherever you listen to your podcasts, and leave us a review. And if you're new to keto, head on over to perfectketo.com/podcast and enter your email for all our top tips and guides on getting started with the ketogenic diet. Thanks, and we'll see you next time.